Multifunctional Screw Drill and Reaming Device by Mr. Leonardo Mohamed. Invention Outline. The invention. The present invention relates to a multifunctional screw drill and reaming device with a unique design. It has many functions, which includes an improved technique in drilling. This drilling technology has advanced to the point where it can now improve various drilling processes, such as drilling oil or water wells while leaving an outer casing, retrieving samples of different materials such as structure, stone, aggregate, sand, grain, or soil at desired depths, and facilitating the extraction and injection of gases and chemicals in different forms. This technology can have broader applications in industries such as mining, construction, and environmental research. Design. An in-depth study of each function of the invention has been provided. Also, a scaled-down prototype of the invention has been constructed for demonstration purposes. Target audience. Geologists and professionals in different disciplines can now apply these new techniques with the benefits to solve many problems. Invention design. The present invention consists of primary and secondary screws where both sets of screws are independently driven. Depending on the operation, the secondary screws can rotate and change position or rotational direction within the primary screw's bore. In addition, both primary and secondary screws can be coupled and rotated as a single unit. The screws can be hydraulically, pneumatically, mechanically, electrically, or manually driven. Sections of primary and secondary parts may be added for achieving greater depth and soil penetration. Timeline of the invention. In April 2012, the World Intellectual Property Office (WIPO) awarded the inventor certification and honorary medal as the best inventor for 2012. In June 2012, a registered Trinidad patent number was granted to Mr. Leonardo Mohamed. In August 2012, the Trinidad and Tobago government awarded the inventor certification and grant assistance to further enhance the invention. Special permissions for this research and development was required for the inventor. In June 2015, a registered United States patent number was awarded to Mr. Leonardo Mohamed for this multifunctional screw drill and reaming device. Business focus. The multifunctional screw drill and reaming device can make a positive economic impact both locally and internationally by having the capabilities to remove samples from all types of soils, liquids, slurry, granules, grains at any given depth. Our target audience for this invention are investment firms, tool manufacturers, and companies involved in areas such as desalination and potable water plants, humanitarian rescues, environment, agriculture, geological, oil and gas, mining, material sampling, and more. Multifunctional screw drill and reaming device usage. Water filtration management. Portable water plants play a crucial role in ensuring safe and clean drinking water for communities all over the world. One of the key components of these plants is sand filters, which are responsible for removing impurities and particles from the water. With invention, it can assist with portable water plants, sampling and coring of the sand filters, to optimize the efficiency of sand media filters using the patented multifunctional screw drill and reaming testing device. Please see attached presentation. Agriculture. With invention, the method of injection would be useful for testing the qualities of grains and seeds. By injecting chemicals into the soil, farmers can determine the nutrient levels and composition of their crops, allowing them to make informed decisions about fertilization and other necessary treatments. It not only helps to improve the overall health and yield of the crops, but it also reduces the risk of over-fertilization and environmental damage. Additionally, this method can be used for precision planting, as the injection of seeds and bulbs into the soil allows for more accurate and efficient distribution. Furthermore, injecting fertilizer granules directly into the soil reduces the risk of runoff and leaching, ensuring that the nutrients are delivered directly to the plant's roots. Overall, the injection of chemicals and other substances into the soil is a valuable tool for farmers and land managers, providing a more targeted and efficient approach to crop management and land restoration. See also attached presentation for agriculture. Construction. The construction industry is constantly evolving and seeking ways to improve efficiency and safety. With the multifunctional screw drill and reaming device, it can greatly contribute to this goal, including drilling and grouting, soil nailing, simpler and quicker procedures in continuous flight auger piling, gas monitoring, gas injection, horizontal and vertical boring, and extraction and injection. Forestry. Root rot is caused by a fungal infection. It primarily affects the roots of trees and can lead to the death of trees if left untreated. This has become a major concern for environmentalists and scientists, as it can have a devastating impact on the ecosystem. The fungus responsible for root rot thrives in damp and waterlogged soil, making it a common problem in areas with high levels of rainfall. The tool is designed to remove soil from the affected areas for testing, allowing for early detection of the disease. This is crucial in preventing the spread of the infection to other trees. The tool also serves as an injector, which can be used to directly treat the affected areas by injecting necessary chemical solutions to the roots of the trees. This targeted treatment helps to eliminate the fungus and promote the growth of healthy roots. The tool can be effective in treating root rot, saving countless trees from being destroyed. It has also significantly reduced the use of harmful chemicals, making it an environmentally friendly solution. It also helps in understanding the disease better by analyzing the soil and root samples. The invention of this specialized tool for testing and treating root rot has been a game changer in the fight against the destructive disease. Environmental management authorities. It is now possible to remove samples from all types of soils: liquids, slurry, granules, compact soil, seabed or seashore, beach sand, riverbeds or banks, and gravel pits at any given depth. Please see attached presentation. Oil and gas. Sampling. The present invention, with one entry into the subject matter, the said invention can retrieve samples, undisturbed samples or disturbed samples without any cross-contamination at any given depth, and retain the integrity of each sample. It does not have to consolidate unwanted matter with the samples. It can remove only the specific areas required for sampling. While the present invention is moving from depth to depth, no matter enters the sampling bore, and therefore there is no cross-contamination. This invention can be incorporated with the drill bits used for oil exploration and can minimize time spent in drilling and sampling. With one trip of the drill bits within the oil well, in that single trip, samples can be removed at any depth. Humanitarian. This apparatus is considered a humanitarian device, where it can save lives of people trapped underground, for example, earthquake victims, underground exploration, and trapped miners, etc. This apparatus can reach and pump oxygen, food, and water to the victims, and can also remove dangerous underground gases. Environment. This apparatus can also be very useful to the environment by assisting in sealing up leaking oil wells. It can reach the affected area and, if required, inject the appropriate sealing solution, or the apparatus can remove the contaminants. oil sands, tar sands, or bituminous sands mining. This apparatus can also be used for the injection of steam, solvents, and/or hot air into the sands or earth as to separate oil from the sands. CFA piling using the existing method. Continuous flight auger piles are suitable for most soil conditions and, being virtually vibration-free, can be installed in close proximity to existing buildings. These piles can be also installed in non-cohesive and water-bearing soils such as sand, gravels, and glacial tills, as well as cohesive materials such as clay and weak rock. These piles are produced by drilling into the ground with a hollow-stemmed continuous flight auger to the required depth or degree of resistance. Concrete is then pumped down the stem of the auger. While the concrete is pumped, the auger is slowly withdrawn, lifting the soil on the flights. A shaft of fluid concrete is formed to the ground level. Steel reinforcement is then inserted into the concrete piles to the required depth. CFA piling using the multifunctional screw drill and reaming device. As you can see, after drilling and while the auger is slowly withdrawn, the concrete is pumped down to the ground level. The steel reinforcement is then inserted into the concrete pile to the required depth. Note, the steel reinforcement has to be forced down after the concrete is poured. Using our new invention for CFA piling, we can drill into the ground, at the same time taking in the steel reinforcement for installation to any required depth. At the required piling depth, the steel reinforcement is anchored into the ground. The outer part of the screw is lifted out, leaving the steel reinforcement. At the same time, the concrete is pumped down the stem of the screw. A shaft of concrete and reinforced steel is formed to ground level. Note, with this new procedure, the steel reinforcement is anchored and then the concrete is poured, eliminating the problem of forcing the steel into the concrete. Boring vertical or horizontal. Together, the action is the boring and removal of debris to eventually reveal a tunnel. No debris is transferred through the primary bore while boring is in operation. The primary screw remains at the desired vertical or horizontal distance and can be used as a pipeline. This pipeline can be used for almost any type of liquid, gas, or electrical cables. This pipeline application can be used for drainage purposes. This pipeline or housing can be used to cast piles or supports in water and soft areas. The primary screws bore can be used as a pipeline under a roadway pass or through a mountain. The main advantage which the present invention has over the prior art is it does not allow any debris to pass through the primary bore like the existing tools, but instead allows the debris to pass at the outer primary screw. The primary screw executes the majority of penetration, and while penetrating, removal of all unwanted material passes on its outer diameter screw. No unwanted material passes through the primary bore. Hence, there is no binding or sticking of the said invention during the operation. Extracting. The invention can also be used as a medium for the extraction of liquid slurry and soil vapor. Extracting, testing, venting. It can move from depth to depth while gas sampling is being done. In addition, this sampling can be done at any given depth. Injecting any type of granule and solid. The tool, when used as an injector, can hold the subject matter for injection, while the tool is in operation and release the matter at the appropriate depth. Injecting any type of gas, slurry, or liquid. A high pressure hose with the product to be injected is connected to the top of the primary bore. The injection tool injects from within the primary bore to the base of the present invention. Injection of gas or liquid may be needed in a larger area, not only at the injection point, but a modified primary screw with drilled holes can also be used to inject. Injection takes place at the injection points and along the drill holes of the primary screw. Having a high pressure hose connected to the present invention is mainly used for gases. Liquids and slurry can be used with a high pressure hose or gravity fed. Here comes to the end of the presentation. Thank you for your attention. Any questions?